Welcome to the video on the LED half adder. What we want to do is we want to build a circuit. So we originally did our exclusive OR just to check that this logic gate works. We want to expand this now to be able to not only add, so you'll notice, I forgot to mention this on the last video, but you'll notice that the output that we had from the first calculation, the exclusive OR, this is the sum of when you're adding two numbers together. So for example, 0 plus 0 should give me, so let me plug my battery back in. 0 plus 0 should give me 0 for the sum. So 0 plus 0 should give me 0 ones plus 0 twos. When I do 1 plus 0, or 0 plus 1, I should have 1 1 and 0 twos. When I do 1 plus 0, again I should have 1 1 and 0 twos. When I do 1 plus 1, I should have 0 ones, but I should have 1 2. So the goal of going from what we did with just a single XOR gate to now this half adder circuit is we want to now create an output for S1 to be the carry. So in the case that both of these are on, we want to have S1 to be 1. There should be 1 2 if I add a 1 and a 1 together. So what logic operation gives me a 0 twos, so I always have 0, unless both of these are on? So the answer is that the output is on if and only if both of these are on. So I need B0 on and I need A0 on in order to do S1. So in order to build the half adder, we're going to need to add an AND gate. So overall, for the half adder, we now need 6 small green jumper wires. We need an AND logic gate, so we need that also. We need the 4, we're going to need, instead of just 2, we need 4 of these now, medium length orange wires, and then 1 medium yellow and 1 long purple for the output. Now, unfortunately, I don't have those for my demo. So what I do have is my short powers. I'm going to have a yellow and I'm going to have a green for my second power. So I have these that are available. And then I have 3. So I have these 2 extra. These are supposed to be the orange ones. They're purple. And then I have my 1 long purple output. So let's unplug our circuit and let's talk about how we're going to build this half adder. So we took the battery out of the battery clip. We're going to leave this first part because this is actually what we're doing to compute the sum, and we just need to expand it to do the carry. So go ahead and set aside these batteries, the breadboard, the logic gate, and the wires. What we're going to do is we're going to work on this worksheet. So the worksheet helps us to figure out how we're going to plug up to create a half adder. So the picture, in terms of what's needed, it tells you the components that are needed. It tells you where to plug in the different pins so that we have a consistent solution that's easy to check. So this is why we had plugged in the 5-volt pin in column 9 and why we plugged in the 5-volt connection for this first XOR gate into column 16. So that's this. So we have 9 and 16. So in terms of the wiring diagram, what we've already computed, or what we've already done, is we've already put the 5 volts, we've connected it to column 9, so we've taken this, the 5 volts, and we've put it here. We've taken for column 16, we've taken from 16 to 16J, we've done that. And then for ground, we've gone from column 4 to the ground, 4A. And we've done 22, which is the ground for the XOR gate. So those 4 we've done already. And now what we want to do is we want to fill out this table. So what this is showing is it's showing where the pins are. So you'll notice that for A0, A0 is in column 6, and this U means it's on the upper half. So these 5, this is U upper, and this is L lower. So there's the upper half of the board, the lower half of the board, and that's the notation we'll use. So you'll see A0 is in column 6U, and B0 is in column 8U. So it's in 8 in the upper half. And where we've plugged it in we've plugged in 6U, which is this orange. We've plugged it into 17U. And we've taken 8U and we've plugged it into 18U. So that's what these two orange wires are. That's this connection from 6U to 16U and from 8U to 18U. So those connections are already made. We've taken the output from 19U and we've plugged it into S0. So that's this connection. We've already made that connection. So this wire, and this wire are already made in our circuit. And now what we want to do is we want to do XOR. So we said, we want to do half adder. So we said that the second LED, the carry of the sum, or the carry of the, when you add those two numbers together, this is going to be the carry configuration. We're going to say that it's the output of the AND logic gate. And the inputs are those two switches A0 and B0. So for this, what we want to do is we want to label where these things are going to be plugged in. Now, the instructions say to put the AND, the 5-volt pin, which is pin 14, to put that in 27F. So this is my AND gate, and I notice that actually my pin is bent again. So let me straighten this out. So when you get your parts, they should be in pretty good shape. I think mine have gotten bent because I've plugged in and unplugged them several times. So we want this pin, the 5-volt pin for the logic gate, we want that to be in 27F. So we're going to plug this in into 27, so 25, 26, 27. We're going to plug it into 27F. And we have to check that all our pins are lined up. Okay, and then we look at it from the side, and we can see all of our pins are plugged in correctly. So we have 27F for the AND gate. So we've plugged this in already, we plugged this in, and we just plugged that one in. Okay, so now what we're also going to do is we want to plug in the wires from these inputs into the AND gate. And the reason that we have this worksheet is so that you can see and make sure you understand which pins things are going into. So if we remember the AND gate, or any of these logic gates, the other thing to notice is that there's this curved semicircle, so the semicircle needs to point on the left side. So this is pin 14, this needs 5 volts. That's why it says here to plug in 27J to 27J to the positive rail 27 plus. So we can go ahead and do that. So we plug in, and remember, we've disconnected the battery. So we can plug in from 27 to 27 plus. So you'll notice that this is like the start of where the 5 things are. That's why we plugged this one in here rather than shifted over one or so. It's just lining up the pins and so forth. So we've plugged in 27J to 27 plus. And then the ground, which is pin number 7, which is in column 33, we have to go from 33A to 33 ground. So you'll use a small green wire. I don't have green, so I'm going to use yellow for 33. Okay, so I've now put 5 volts connected to pin 14 and ground connected to pin 7. Okay, so I've completed those connections. And again, the reason we have the worksheet is to make sure that we've made all of the connections that we need to for this to work. All right, so now the last phase is we need to do the AND operation. So the AND that we're using is AND number 4. And if you remember these configurations, this is gate number 4. It's the upper left corner. Gate 3 is the upper right corner. Gate 1 is the lower left corner. Gate 2 is the lower right corner. So what we need to do, if we notice this carefully, so gate 4, it says 28, 29, 30U. So that's here. This is 28, 29, 30, and it's in the upper half. So these tell us which pins or which columns these pins are plugged into. So what we want to do in order for the output of A0, we need that to go to the input of the AND gate. So the input pin of the AND gate we see is in column 28, and it's in the upper. So this is 28U that we're going to plug in from the input to here. And this one, it's going to be in column 29 in the upper. So those are the two inputs for this AND gate number 4. The output is now this pin, or this column 30. So the output is 30U. Okay, so now we're ready to wire it. You're going to take, ideally, 2 orange wires. Mine are purple, so you're going to do orange. And what you want is you want to wire from here, which is in 17U. So this, you could take it from 6, but it's more convenient to take it from 17. So we're going to go from 17 upper into 28 upper. So with one of your orange wires, you're going to go from 17 upper, which is there, into 28 upper, which is there. All right, so that one's giving me a little bit of trouble. So 17 upper is here, 28 upper is there. So I've plugged that in. So that's this cable here that I've completed. So that one's done. So now the last cable that I need on the input side is I need to go from 18 upper to 29 upper. So with your other short orange cable, go from from 18 upper, which is here, into 29 upper, which is there. Okay, so I've gone from 18 to 29. So that takes care of this wire. Okay, so I've taken care of all the wires. The last wire I'm missing is I need to take now the output of the AND gate and plug it into the input of the second LED. So I need to go from the output of the AND gate to the second LED. So you'll see that I go from 30U to 7L. And this is why I wanted to have this long purple wire, because this is a pretty long connection. So I'm going from 30 in the upper, so I pick somewhere here, and I go from 30 upper, that's this side, and I'm going to go to 7 lower. So you see the output of the AND gate is in the 30 upper, the input of the LED is in the 7 lower. So this has now completed my LED half adder. So this, what it should be able to do is to do additions such as 0, so we have our 1s column, we have our 2s column. So I should be able to add 0 plus 0 and give me 0, 0 1s and 0 2s, 1s and 2s. I should add 0 and 1, get 1 1 and 0 2s. I should be able to do 1 plus 0 and get 1 1 and 0 2s. And I should be able to do 1 1 plus 1 1 should give me 2 1s, but I can't represent 2 with binary, so I should have 0 1s and 1 2. Okay, so that's the goal. The goal is to be able to build this half adder circuit such that this column, the 1s column, this is my sum, and this column is my carry. So normally when you add, like if I had 6 plus 4, I would say that there's 0 1s and I would carry it, I'd have 1 10. We're working base 2. So what this says is if I add 1 1 plus another 1, I should have 0 1s and I should carry and have 1 2. So again, this is the carry and this is the sum. Okay, so let's test this out now. Move the sheet out of the way. So this is our logic circuit. We're going to check that all of the pins are plugged in. We're going to check that we have 5 volts going into pin 14 in the upper left corner. We have 5 volts going into the upper left corner. We have ground going into the lower right corner, ground going into the lower right corner. We have the outputs of the switches going into inputs of logic gates. The output of the logic gate goes to a light. These intermediate wires, they're actually still connecting from the switch. So the switch is at the same voltage as this intermediate input. So that's just kind of just daisy chaining and jumping the voltage to over here. So this is going into the input of the logic gate, and then the output of the logic gate goes into our light emitting diode. So now we're ready to do some addition and test this out. Okay, so I've turned these both to switch off. I have my 9-volt battery. I'm ready to plug it in. Okay, so the first calculation is we want to see that 0 plus 0 gives me 0. So with these both at 0, I have no 1s and I have no 2s. So this is correct. Now I want to do 0 plus 1. So 0 plus 1, the 1s is on, so I have 1, 1, and I have no 2s. So that's correct. So I'll turn that off. I'll turn this one on, and now I'm doing 1 plus 0. So 1, 1 plus 0 is 1, and no carry, so no 2s. And now for the time of magic, if I add 1 plus 1, what I'm doing is I get a sum of 0. So I have 0 1s, and I have 1 2. So I've just added numbers as high as 1 plus 1 and displayed the light, or displayed the result as light emitting diodes. And I've done the calculation in binary, which is how computers do their calculations.